All right, so these are the notes for 4.3. This time we're going to go ahead and we are going to solve the equations by addition. So the idea behind an addition is if I have an equation where A is equal to B and I have another equation where C is equal to D, if I were to add the two left-hand sides and add the two right-hand sides, I would also end up with a true equation, which is why we are able to either add or subtract, by the way, equations to get an equivalent equation. So here we go. If we look at example 1, the idea is that you want to make one of the variables drop out. It doesn't matter if it's x or y. You want to add the two equations to make one of the variables drop out. Well, if we look at these two equations, we're starting off easy. Do you see if I were to add these two equations, the y's would drop out because y plus negative y is equal to 0. So that's what we're going to do. We're going to add these two equations. So x plus x is 2x is equal to, the y's drop out, 7 plus 5 is 12, which means x is equal to 6. We have found the x-coordinate of our solution. I can now go up and into either one of these two equations. I'm going to go into the top one. I can plug in my x to be able to find the y that pairs with that. So 6 plus y is equal to 7. If I subtract 6, y is equal to 1. So my ordered pair solution is the ordered pair 6, 1. If x is 6 and y is 1, it fits into both of the equations. And once again, graphically, it means that if I were to graph these two equations on a graph, they would cross at the point 6, 1. Okay, let's look at the second one. Now, if you analyze the second one, you'll notice, if I just add the two equations right now, nothing's going to drop out. So what we have to do is we have to multiply one or both of the equations by some value to make either the x or the y drop out. And it doesn't matter which one you do, x or y. I think I'm going to do the y's. So if I want to add these two terms and have the y's drop out, since this is a 3y, do you see that I would want this to be a negative 3y? Because negative 3y plus 3y would drop out. They would equal 0. How would I make this a negative 3y? I would have to multiply everything through by negative 3. So let's see what happens when we do that. Negative 3 times negative 2, that's going to give me 6x minus 3y equals negative 6. Don't forget to multiply this also. And then I'm just going to rewrite the other equation. I like them right together here. And now I can go ahead and do my addition because my y's are going to drop out. I'm going to get 5x, because that's 6x minus 1x, is equal to, if I add these, I get negative 10. So my x is negative 2. And once again, to find the y, I'm going to go up into either one of the two originals. It doesn't matter. I think I'm going to go up into the top one. And wherever I see an x, I'm going to put negative 2. So negative 2 times negative 2 plus y is equal to 2. 4 plus y is equal to 2. And if I go ahead and subtract 4, I see my y is, interestingly enough, also negative 2. So the solution to this system is going to be negative 2, negative 2. All right, so what are some of the other things that can happen? Well, we have 2 more examples to do. Now, it is totally up to you, but do you notice that this bottom equation has fractions? Do you really want to work with fractions? I'm guessing not so much. So what I would suggest you do is Let's go ahead and let's multiply everything in this fraction through by the lowest common denominator, which happens to be 2. And that will get rid of the fractions for us. So I'm just rewriting the top equation. If I multiply everything here by 2 over 1, that's going to help me eliminate the fractions. I'm going to get 2 times 1/2 is 1x plus 1y is equal to, don't forget to multiply this also by 2, and we get -6. So much easier to work with. Never work with fractions. Multiply through by the lowest common denominator to get rid of them. Okay, so this is beautiful. Do you see if I were to add them right now, the y's are going to drop out? So I'm going to go ahead and do that. X plus x is 2x is equal to -10. So my x is going to be -5. I'm going to go ahead and plug that back into this one because I don't want to deal with the fractions. And I'm going to plug in -5 for x. So -5 minus y equals -4. Let's add 5. So that's going to be -y equals 1. And if I divide by -1, my y is going to be -1. So my ordered pair solution for this system is the ordered pair -5, -1. Alrighty, last example. So if we look at this system right here, we're solving by addition. So if you look, nothing's going to drop out on its own. So we could do either the x or the y's. Doesn't matter. I think I'm going to do the y's. So let's think about that. If I want the y's to add, to drop out, since this is -4y, do you see where I would want this to be a positive 4y? And what can I multiply this equation by that would make it a positive 4? I'm going to multiply the whole equation by -4. So let's make sure that that works. If I multiply through, I'm going to get -8x plus 4y equals -28. I'm not changing the bottom. Now look what happens when I go ahead and I add these. Those drop out. Those drop out. I have 0 equals -27. What does that mean? It's a false statement. If it's a false statement, it means that these two lines are parallel and there is no solution to the system. So there's the addition method.